Hey, this is Kevin, and here's a quick video on how to make a knife in 3 hours. I hope you enjoy. Today I'll be using 1084 high carbon steel because it's easy to forge and much more forgiving when heat treating. I start by using a heavy 5-pound hammer to shape the tip of the knife. At the same time, I'm making sure the steel stays flat and straight between each of the heating cycles. Now that the rough forging is complete, I drop down to a 3.5-pound rounding hammer. This refines the overall shape and cleans up our outline so I can move on to forging in the blade bevels.
I need to straighten this out, clean this up a little bit, and then we'll put the bevels in. And what's going to happen is the steel will smooth up.
I start beveling with a 3-pound doghead hammer. Then I move to a 2.5-pound front weighted hammer, working both sides of the steel equally. I use a 2-pound brass hammer to straighten the blade and flatten the spine. Because brass is soft, it won't mar the steel. Squirrel! Back to setting the final bevels. I could use a cutting hardy on my anvil, but I cheat and use the metal cutting bandsaw instead. Using the natural curves of the anvil horn, I create a comfortable handle about 5 inches in length. I use a ball peen hammer to add some texturing to the knife. The knife is straight and forging is complete. The hot steel is now put into a bucket of vermiculite to slowly cool and anneal. This process leaves the steel soft, so it's easy to grind and drill. Time to choose the handle material. I've got wood, lots of it. The knife is cooled and it's ready for the grinder. I start with a 60 grit belt, refining the bevels and thinning the blade as I go. I use the wheels on the grinder to further the profile and contour the handle. Next, I'll mark and drill holes for the handle pins that will secure the wood scales to the tang. Time to choose some classy mosaic pins for this knife handle. Using a kiln, I'll heat this railroad spike up to 1500 degrees. The spike will be used to preheat the quench oil. Cold oil could cause the knife to crack or warp once quenched. Time to trace the handle so I can rough cut it on the bandsaw and drill the pinholes. It's important to finish the top of the handle before glue up. Once pinned to the tang, you won't be able to sand this area. Drilling small pockets into the handle material allows the epoxy to pull and cover more surface area, creating a superior bond. The next step in the process is normalizing, heating the steel to critical or non-magnetic temperature and letting it cool to room temperature. This is done 3 times to relieve stress from the forging and grinding. I consider this additional insurance that the blade won't crack. Time for the most important step in the process, the quench. Taking the steel up to critical temperature and cooling it quickly in oil. The steel has now transformed from austenite to martensite. Martensite is the maximum hardness of the steel, which is brittle and can shatter like glass if dropped. I tempered the knife in a toaster oven at 450 degrees for 2 hours. This time was not included in my 3-hour work time. Back on the grinder, using a 220 grit belt, cleaning up the oxidation, and moving up through the grits to 600. I scuff the handle and mix the epoxy. Time to glue the handle to the tang and insert the pins. Clamp it up and wait for the epoxy to set. The glue is dry, so I can start shaping the handle on the grinder. Once the handle is shaped to 80% and brought up to a 220 grit, I finish sanding by hand and buff the handle to a bright luster. The final step is putting the cutting edge on the blade. I use a 240 grit belt, polish with a card wheel, and then strop with a leather belt. After 3 hours total work time plus 2 hours for tempering, we now have a fully functional knife. Normally I spend 14 to 16 hours on a chef knife, so the final fit and finish is absolutely perfect. And as you can see, a lot of work goes into making a knife, but the final product will give you a lifetime of use.